Welcome back to Talkin Shop with ShopSabre. I'm Brandon, back with Chad and Garrett today. How you guys doing?
I'm doing great.
I'm a little sore, but not too bad.
Yeah.
I guess I'm sore too.
Yeah, say both you guys are pretty sore, it sounds like. We're episode 74 today.
Uh-oh.
74. Here we go.
We're getting up there.
We don't have Jesse, though. Jesse's busy, so the show must go on. Actually, we're going to kind of change the formatting a little bit. We're going to start inviting some of the other guys in the episode periodically. So moving forward, it'll be the three of us plus a guest, right?
Yep, meeting the team.
If we can convince him.
Oh, we're going to convince them. We're just going to roll their chair in here. They have no choice. There's three of us.
I guess if we could get Chad in here, we could get any of those guys.
Yeah,
in
that's
here.
what I'm saying. Chad's here, so basically they don't have any excuses.
Exactly.
Chad's bigger than all of them, too, so we'll have to carry him.
Oh, yeah. I was about to say I'll muscle him in there.
Just pick them up. No. Okay, Chad, get in here. But, yeah, so you guys are sore because you tried out for the Live Tour this weekend,
Yep.
and you decided you wanted to start working out again.
Yep.
Yeah, so, Chad, did you make the Live Tour?
No.
Did not make the Live Tour.
Golfing 2 rounds in a day is not fun.
No,
It's-
pretty hard on the
How was
body.
your vacation, Chad?
It was fun. It was
Yeah.
a great time. All inclusive. So the steak was free. The prime rib was, well, I guess not free. I had to pay
You had to pay for it up front, but it didn't feel the same.
Yeah. Well, then you had to leave a tip. So, like, you're still dealing out cash. So, yeah, I don't know. It was a good time.
Somehow it was all inclusive, but I wasn't, and I don't understand what happened here. I just lost money. No, that's awesome. You
Yeah.
had a good time.
Oh, great time, yeah.
Did you bring a steak in your pocket?
No.
You didn't bring anything home for me. Unbelievable.
No.
It was all inclusive, bro. You just bring a to-go bag and you put it in there for
Well,
me.
they gave you stamps for the food.
Oh, really?
But then it was just a wristband for like the guys who were drinking. They could
That's
just
cool.
go up and
That's cool.
flash the wristband to get whatever they wanted. So Garrett would have had a doozy of a time.
Garrett wouldn't have remembered anything. And you started working out,
I did.
and now today your back is destroyed.
Yeah, you probably should ease into it.
Yeah.
I used to work out, and then I stopped when I moved. But now I figured I'd get back into it. And
What were you benching? 20, 30 pounds?
I haven't benched yet.
Well, he's going to start hanging out with an Olympic wrestler. So he needs
That's what I heard.
Needs to be buff.
He needs to be buff now because he's going to be trying out for the Olympics, apparently.
Yeah,
God, you guys are so much cooler than me. Yeah, that's a doozy of a time. Is that all you did this weekend was work out?
No.
What'd you do?
Sunday, I sat on the couch and watched football for about 12 hours, which was great.
Solid.
always
Solid
a
use
fun
of time.
day.
Saturday, I bought a dishwasher. I had to spend $600 because my dishwasher broke.
Oh, you're having to be an adult?
Yeah.
Oh, exciting.
Yeah. Didn't do a whole lot. Went and hung out with some friends at a bonfire for like 3-4 hours and then went home and relaxed. So, yeah.
I think you were out of town too, Brandon, weren't you?
Yeah, I was out of town. We went racing.
Smashed up the car.
Yeah, got wrecked coming to the green flag. That was nice. Didn't even get to take the green flag. We just got wrecked by the guy that was on the inside of us. He just didn't turn. So destroyed us. We spent all night long thrashing on the car. And we ended up winning the feature with a tore up race car.
That's pretty awesome.
Yeah, we went from last to first. Had a ratchet strap holding the hood on the car. So that was pretty cool. But nevertheless, it's not about how pretty they are. It's about how fast they are. And we made it go fast.
That's awesome.
So yeah, it
Is
was
that
good.
what they say?
That's what they say. It's not about how pretty it is. Not a beauty contest. Trust me, my car is not pretty. It has seen better days. But yeah, and then now we're here.
Back at it.
Back at it. We got that phone system they're installing today.
That's pretty exciting.
Yeah, it's exciting, but I'm nervous because they're moving all of our phones around and I'm just waiting. You know how everything is going smooth and like you're like, it's going to happen. There's something that's got to go wrong here.
Phones will be down for 2.5 days.
As soon as I get out of this meeting, the phones will be down. You watch.
Yep.
But yeah, so that's what our day's been. It's been a crazy day today as we run around. But, I thought, last week's episode about empowering employees was a pretty good episode. But I feel like this week we should talk a little bit about more CNC direct relation, which I'm talking more about like specifically the motors, servos and stepper motors.
It's a good topic.
Yeah.
You talking about a car motor or what's that?
No, not a car motor. No, the servo and stepper motors are what makes the machine move, the actual motion. Not necessarily talking about the cutting heads, like the routers themselves, but the actual motion. So whether you're buying a plasma or a laser, water jet, router, it doesn't matter. They have some sort of a drive motor on them that makes the machine move. In fact, your printers have those in them. Did you know that? Mm-hmm. Yeah, your printers have stepper motors in them. So yeah, there's lots of applications worldwide where a motor comes into play. In fact, I was at the racetrack this weekend. We were using a tire grinding machine, and the guy turned his tire grinding machine on, and I noticed, there's a motor on it. It's got a little stepper motor on it, and just makes the tire spin. So I started looking at it, and I'm like, I'm not gonna buy one of those. I'll just build one. So I'm gonna have Billy build me a tire grinding stand. That's gonna be awesome.
I also
Sweet.
had a motor encounter this weekend.
Yeah.
Mine in the dishwasher no longer works.
Yeah, all your motor in the dishwasher went out.
Yep.
Is that what it was?
That's what it sounds like. Just goes, just make a really unpleasant noise. No water comes out.
I'm just gonna ask.
It
Are
is
you
plugged in.
sure? No, it sounds like it was plugged in. Are you sure you didn't have a wild animal in there?
No,
Okay.
Was
You're
it
not
a
sure.
stepper motor?
I don't know if it was a stepper.
stepper-
I stepped to check into the motor, but I couldn't see nothing.
That's funny. But so I thought, we get a lot of people who do ask us questions about motors on machines, and I thought it might be a good time to talk about the ins and the outs, kind of the basic information pertaining to servo motors and stepper motors, right?
Yep.
I mean, how many times do you get asked about motors on the machines, do you think?
Daily.
Daily?
Oh yeah.
Yeah. Garrett, how many times do you get asked on social media about motors?
Twice a week.
Do you?
No, maybe a little less than that.
Okay. Yeah, but I mean, it's an obvious question that comes up. I guess let's just kick it off right away. I mean, I guess, what do you guys think about this topic? I mean, you think it's something that you guys can talk a little bit about today?
I think so.
Yeah. What do you think about when you think about stepper motors versus servo motors?
I think that I can't believe that some full-size machines are still out there running stepper motor technology, with the benefits that you get with servos, which I'm sure we're going to get into a little bit more here.
Yeah. No, for sure. I think that's a good point. When you look at like how long CNC has actually been around, and then you look at the technology that is available on the market today, I agree with you. Like it's kind of surprising when you think about like a lot of equipment out there. It's not advancing the way it should be. You see a lot of these machines out there, and I think specifically you see a lot of import machines that they try to talk up how great their spindle is and their vacuum and all this other stuff, but the stuff that like is the most obviously glaring stuff is not upgraded, but yet consumers still buy it.
Mm-hmm.
That's right.
It's one of those things where the motors to me are so obvious, right? I mean, it's the first thing that I look at. And again, I'm in CNC, so it probably is a big part of why I look at that first. But I think a lot of people just go past that. They don't care. They look at, it's kind of like the pickup truck. Not a lot of people ask what engine's in it. They ask, does it have the rims?
Yep.
Right? They want to see the flashy stuff, the fancy stuff. Does it have a tool changer? They don't really care about the actual motors that are driving the machine, more about, does it have a tool changer? Does it have vacuum? It's those things that they think about.
And they're not thinking about the things that they're giving up, like torque and
Yeah.
the other benefits that you get from the servos.
I agree with that. Yeah. I mean, I think that's a great, thing to talk about, is because I feel like we could talk for 4 hours on this and never get through it all. So, I think today we'll kind of stick to the simple stuff, like you were just talking about, the torque and some of that stuff. But, if someone really wants to go in depth on this topic, I'm positive that by phone, any one of our team members here can go through this and talk, more focused on the application and the specifics of each individual motor and actual machine model, right?
Yep.
I think that's something to remember, is that every machine, no matter what you look at, has a different motor potential, because, different ratings are for different, applications, high torque, high speed, such, different motors will come on different things. If you look at a stepper motor that's on a inkjet printer, it's much different than a stepper motor that's going to be on a CNC machine. At least you hope,
The hell's the difference between the two motors?
Yeah, I mean, you talking about servo versus stepper?
Yeah.
Yeah, I mean, that's a good, let's talk a little bit about that. Garrett, I'm glad you jumped in there with that. Because I'm sure there's somebody else out there going, what the hell are they even talking about? First, what is a servo motor? Well, it's a rotary actuator or a linear actuator that allows for precision control of angular or linear positioning. It's for velocity and acceleration are all controlled by this. So it consists of a suitable motor coupled to a sensor for positional feedback. Generally, that sensor is considered an encoder. It also requires a relatively sophisticated controller of some sort, often dedicated module designed specifically for the use of a servo motor. It's got to have something that's actually reading out to that motor. Servo motors are not specific class of motor. Just to be clear, servo motors are not a specific class. the term servo motor is often used to refer to a motor suitable for use in a closed loop control system. So servo motors, popular applications for servo motors are typically going to be your robotics, right? CNC machinery, automated manufacturing, those type of things. That's where you see a servo motor. Chad, what's let's just kick it off real quick. You mentioned it earlier, so I'll let you kind of talk about it, but what's one of the advantages to a servo motor there?
You get better torque at high speeds.
Yeah. And that's a huge part of it, because I think a lot of people miss that a stepper motor still can produce high speeds, but you lose a lot of that torque. So you see a lot of machines that use lower quality motors, like they have these really high rapid speeds, right? But then when you look at their cut speeds, they fall off tremendously. You start adding torque to that equation, and it's like the machines just can't do what they need to do.
And I think that's why those companies like showing off the rapid versus cut speeds.
Correct. I agree with that. I think the other advantage to a servo motor is, of course, you get some smooth motion. You get really smooth motion out of it. Generally, because of that smooth motion and the better torque, you're going to get 2 to 3 times the speed of a comparable stepper motor. And that is important because speed is relative. I always tell everybody that speed isn't just speed. And the reason I say that is you have to think about speed as acceleration as well and deceleration. And a servo motor can do that very well because of the fact that it has that higher torque. So you have to also think about getting in and out of geometry, as you're doing certain things. There's some real advantages to a servo motor because of the fact that you are able to accelerate so much quicker.
Especially on like plasma cutting where maintaining a speed is so important.
Correct. Yeah, because you have that flame curve, right? Yep. And you get into a corner, and the slower you are in that corner, the more heat you're putting there. So I agree with that. There's a lot of stuff to think about there. You get less noise typically from a servo motor. There's less going on there. You get in terms of noise, like literally sound. They're quiet a lot of times. They're more efficient. They take less power to actually run those machines. So that's another advantage to that. And before we get too far into servos, let's answer Garrett's question though. So that's what we know about servos, right? Steppers. What's a stepper motor? Well, it's a brushless. It's a brushless, typically DC electric motor. It divides a full rotation into a number of equal steps, is what it does. The motor's position can be commanded to move and hold at one of these steps without any positioning sensor or feedback. So there's no encoder typically on that. It's an open loop system. As long as the motor is correctly sized for the application and the necessary torque and speeds, you typically don't have an issue with these. Now, before we talk about what happens if it's not, let's talk about some of the advantages to a stepper motor. Well, they're lower cost, right?
Yep.
Typically, that's why you see them on cheaper machines. That a lower cost control, system can be used. Now, again, going back to your topic from earlier with a stepper motor, you had mentioned torque on a servo, correct? But what about the torque on a stepper motor?
They have high torque at low speeds.
Yeah. So relatively your startup speeds, right?
Correct.
You do get a lot of torque on slower speeds. So if you're not rapiding at high speeds or you have a machine that's not going to be going long distances, stepper motors work really well because you're not achieving speed, right? I mean, that's why you see a lot of desktop machines and a lot of smaller machines run stepper motors efficiently because you're not carrying that 12 feet. You're going 12 inches, right?
And you're not putting as much force on it either,
correct? Yeah, not as much load goes against those. So, again, when you look at a printer, they can get away with it because there's not a lot of force against your printer, right? It's going a short distance. That's why you can get away with that. A lot of the desktop machines, that's why you can get away with them because generally speaking, on a desktop machine, they're not used for as heavy of applications, right? It's generally lighter duty uses. So therefore, you're not applying as much outside forces. It's also why on some plasma applications, you do see it. It keeps the cost down, as we said, but there's not a lot of torque requirements when you're talking about plasma, right? You're not typically putting a lot of force against that plasma head, lasers, things like that. Now, another advantage of a stepper motor is its ruggedness, right? There's not a lot of parts to fail. There's no sensors. There's nothing really in it. It's basically magnets, right? It's magnets and windings inside the motor. That's really what it is. From a simplicity of the construction, they're pretty easy. You don't have a lot that goes wrong there. So, that's some of the basics of that. Now, to talk a little bit about that, let's talk. We talked a little about servos versus steppers, and really that brushless DC electronic aspect of it, right? when we talked about the word open loop versus closed loop, like a positioning sensor or an encoder, as people refer to them, is what tells the machine where it's at any given moment, right?
Yep.
That's an advantage to a servo. Now, with that servo motor, it's going to provide that positioning information back. Now, where that information goes ultimately is determined by the level of machine you buy. That information is either going back just to the amplifier inside the controller, and it's going to either display an error message if something happens, or the alternative is you have a controller that has feedback control, meaning it's going to display that something has changed or something's happened, and the controller is intelligent enough to make a change on the fly. Now, generally speaking, you do not start to see that stuff until you get to $100,000 in equipment. So I can tell you for a fact that a lot of servo control machines don't change the accuracy or change anything on the fly. They're going to display some sort of a data communication error, and then it is up to the operator at that point to make or correct the issue. And that is the difference between a $150,000 machine and a $50,000 machine. That is your biggest difference there, is that the operator has a functionality there.
So what's up with the closed loop, open loop stuff? What is that all about?
Yeah, so open loop essentially means the information goes nowhere. The motor is basically dumb. I mean, just to put a, kind of blank there for you, it is your dumbest person you can deal with, right? I mean, that is what it is.
No.
It's really, when it comes down to it, is your open loop controller is only as intelligent as the operator. And I say that because if you don't know what you're doing, you can mess a lot of stuff up really fast, right? Because you can miss a step. Again, let's go back to the what is a stepper motor when we talked about that earlier. Like I said, it divides a full rotation into a number of equal steps. So when you hear the word missing a step, that's what that is. It means the motor, the magnets essentially, or the winding inside the motor, was not able to accurately complete its turn. So what happens here? So you apply forces in an open loop system. So you add torque, and typically that force is outside force, right? Let's talk about routers or milling, right? You have a bit, you're rotating that bit through a piece of material. That's an outside force. You're applying it towards the machine. So essentially the motor is turning and obviously causing the machine to move forward. Well, if the forces on the outside of the motor are greater than the torque capabilities of that motor, you miss a step. What that means is the machine itself thinks it moved. Okay, as an example, you tell it to go 10 steps, right? But it only went 9. The machine thinks it went 10. It has no way of knowing that it only went 9. You know how you know it only went 9?
You saw it miss a step.
Yeah.
Counted
No, you didn't count it. No, that's wrong.
Oh.
The next step is going to be random. And the reason I mean that is because the machine thinks it's at position 10, right? So the next, as an example, you tell it to take 10 steps forward, 3 steps right, and then 2 steps backwards. That's the movement that the file's telling it to do. But it only took 9 steps the first time. Its next move is still 2 steps to the right? Mm-hmm. Well, you're expecting it to go to 10. So that move is random because it's not where you thought it was going to turn. So what that means? It means you hit your clamps on the table. That means you run into your tool changer. That means you destroy the material you're cutting on. You do something and you have a problem. Now, some errors are simply you just cut your material wrong and you got to start over, right? But some errors are you ran into your tool changer and you just destroyed a bunch of stuff. That is the concern you run into with missing a step. That is why when you said earlier, Chad, God, I'm surprised these big machines still have stepper motors on it. It is surprising, right? Mm-hmm. Is that what we concern ourselves about? Like when we talk to customers, I mean, is that not part of the process? Is like safety?
Oh yeah, huge part of the process.
Yeah. So realistically, when you start looking at stepper motors, there's some safety to be considered in that too, right?
Oh yeah.
And as you go through it, so that's your open loop side of it. Your closed loop side of it is what happens. Let's take that same scenario with a servo motor. You tell it to go 10 steps, right? It's going to go to the measurement of where 10 steps would be. But something happens. The motor sees that you're over torquing it. You're doing something it can't do. It stops in its tracks and either displays an error, right? Mm-hmm. And says on the screen, servo is offline, right? Something happened. So then the operator goes, okay, I did something wrong. I have to fix something. Nobody got hurt. Machine didn't run into the tool changer, and it didn't break a bit, didn't wreck material, nothing. It just stopped. You now can correct the issue. Or if you buy a $150,000 machine and you tell it to do that, it's going to change the loads. It's going to change itself on the fly and go, I can't go that fast without missing a step, so I'm going to slow down.
So am I understanding this correct in the fact that it's like a GPS?
It's a GPS system. Exactly. I love that. That's a good way of putting it. It is a GPS system in your machine, essentially. It is the easiest way to say that is, I'm going to tell you right now, Garrett, get in the truck and drive to Yuma, Arizona.
I could, but it's going to take a while.
Okay. How are you going to do it, though? You're going to probably type Yuma, Arizona into your GPS on your phone, right?
Yeah.
Okay. And you're going to get there, correct?
Yep.
I mean, the GPS is going to give you directions. As long as you follow those directions, you're going to get there. Mm-hmm. Now, if I told you to get in the truck and I took your phone away from you and told you to get there, are you getting there as easy?
Not as easy.
It's going to take some more work, right? Mm-hmm. You got to go pull a map out. You got to figure it out. But what happens if you miss one turn along the way? With the GPS, it's going to be yelling at you, right?
Just reroute you.
Yeah. I call my GPS Amy because it always yells at me. So whenever I miss a turn, I just yell at my truck and I'm like, don't tell me what to do, Amy. She doesn't think it's as funny as I do, but I think it's hilarious. But the difference without GPS, if I miss that turn, I don't know till I realize it down the road, right? Mm-hmm. And you get to the next turn and you realize, I didn't go the right way, right? Or if you think you turned the right way and you turn the wrong way and you keep following those directions, you're not going to end up in Yuma. You're going to end up somewhere random, right? Mm-hmm. And that's how you find out that, okay, I missed a step, right? It's that same thing in your CNC machine. Essentially, it's a mini GPS for the machine. It knows where it's at any given time, and it's following that file. So that's a great way of putting it. That was a really good one there, Garrett. But the reality is servo motors are generally used in a high-performance situation, right? Alternative to stepper motors, which generally are going to be found in a more affordable application, let's call it.
Cost-friendly.
Cost-friendly, yeah. Because, there's a place for steppers in the world.
Absolutely.
Stepper motors have some, inherent ability to control position, obviously, as long as they're built with the correct specs, right? They have built-in output steps, right? It just is what it is. But if you size a stepper motor correctly for the application, you should have zero issues. They can be used with an open controller, so it's going to be cheaper typically to buy a control system that doesn't have to worry about any feedback coming to it. It's easier to wire. They're much cheaper to wire. Without any feedback encoders, their drive signal is specifically just a number of steps and movements. So there are some advantages there from a cost perspective. The lack of feedback of a stepper motor limits its performance, though. The stepper motors can only drive a load that's within its capacity. So if I put a certain size stepper motor on there, I have to make sure that load always stays under that capacity. Otherwise, it's going to just simply miss a step. And under load, it may lead to a positioning error, and you're going to have problems. So as long as you can know confidently that whoever built your machine or built the piece of equipment did all their calculations and engineering correctly, you should never have a problem. 90% of people have no idea how to calculate it. I'm just going to be honest. You fell over your chair there? Sound like you fell out of your chair there.
Mic running away from you?
I was going to drop my mic.
Mic drop. Yeah, it was a perfect time to do a mic drop. I like that. You like that? You like that? It's a sore subject right now with Kirk Cousins, isn't it, Garrett?
Don't bring it up.
Sorry. The Vikings got their butt kicked last night.
He doesn't do good Monday nights.
He doesn't, yeah.
We knew that.
Yeah, we knew going into it we were going to lose. But nevertheless, the positioning errors that you get, the system has to be restarted and recalibrated, obviously. The encoder and the controller, with the encoder controllers, in general, whatever you use that drives the servo motor, plus the servo motor and all of it, has additional cost. There's some cost to be factored in there. So that's what I say to people when you look at machines that do cost less money than ours. Those are some of the things you got to look at because generally that's where they're saving money. They just don't have the technology. That's why they can charge cheaper. They're not just charging cheaper with the same technology, or they'd be charging the same price. That's why you pay less. When you start looking at that, though, it can optimize the performance, of the overall system. For example, you're going to get better speed, right? Better power, accuracy. Typically in those type of applications with servos, you're going to find an increase in all those categories.
Correct.
There's not too many times that you find that to be less. Now, again, that's all relative to the capacity of the basic motors, of course. With larger systems, you have to have a more powerful motor, increases proportionally with the system cost. Generally, more expensive machines have higher torque motors on them. It's generally not the other way around, you know? You pay for horsepower, right? You pay for torque. Servo motors generally have a performance advantage. I mean, simple as that. Servos versus steppers, head-to-head, a servo motor generally is a performance advantage.
And we could always go back to, you look at the higher end machines.
Yeah.
You know,
The more money you spend.
100,000 plus, they're not
Yeah.
stepper driven machines.
Correct. They always typically are a servo motor at that point. You know, and
Even the companies that sell stepper driven machines on their higher end ones will use servos
yeah,
most of the time.
yeah, that's correct. And that's a good point. You know, even us, look, we're one of those companies. We sell several lines of machines, but our lower cost machine is stepper driven. As you go up in cost, the motor quality goes up, and so does the performance of the machine. You know, respectively, you kind of get what you pay for, right? I can't
Exactly.
build you a $9,000 machine that's going to perform like a $100,000 machine. There's a reason why it's a $100,000 machine. So, you know, there have been increasing popularity, obviously, in closed loop stepper motors in recent years. I will say that. They act like a servo motor, but have some differences in their software control to get a smooth motion. The main benefit of the closed loop stepper is that it's still relatively low cost. There's no need to tune, you know, like the controller itself. You don't have any tuning to do. On the closed loop system, it's just closed loop at the motor. But, you know, generally speaking, again, they have their limitations still because they're not true closed loop. They're not able to provide as much data or information. You're not getting errors. It just knows that it missed a step, so it stops itself. But the issue you run into is you don't know why. You don't know what happened. It's really kind of, you better be pretty good, right? You know, many applications such as CNC routers, though, and plasma machines, you know, they may offer two ranges. Like I said, low price ranges using stepper motors, and some may use a closed loop stepper. But the higher performing machines are all going to be true servo motors. You're rarely going to see a high performing machine with stepper motors on it. It's just not possible. You just can't get the technology you need. You know, so you have to start looking at it from that aspect of it, that servos and steppers have a place in this world, both of them. But it really comes down to what are you trying to do? Really, you have to understand your own needs before a sales guy's ever going to be able to tell you truly what you need. You know, because if a sales guy doesn't ask you what you're cutting, like if he doesn't truly, like if you call him up and say, hey, I'm interested in one of your machines. If the first thing out of his mouth isn't, what are you doing? He's a sales guy. He's not there to take care of you. You're going to set yourself up for failure later on.
Is there specific applications within the CNC world that you would choose one of these over the other? Like if you're cutting a specific thing, or is it not really like that?
ShopSabre.com. That's a good place to go find some information. But no, you are correct. There are applications, you know, lighter duty applications, right? Chad, I mean, when would you say to a customer that, you know, it's okay to consider having stepper motors on a machine?
I want to build cribbage boards in my garage one at a time,
Yeah.
here and there.
Yeah. Kind of a
I
hobby.
want to build a sign here and there.
Yeah. Somebody who's not running this machine very often,
Yeah.
right? They might run it once a week.
Maybe. Yeah, that'd be about it.
Yeah. You know, lighter applications,
Yeah.
guys cutting foam all day long, right?
Not in a production setting.
Yeah, exactly. He's doing something where it's like, hey, we're cutting light duty materials all day long. It's really not a lot of force against the machine. I don't have a lot of money. You know, I always tell everybody, if you have a shoebox full of money and that's all you have, you know, you're better to get certain technologies and give up other technology, right? Than to try to get all the bells and whistles at a cheap price. So I will tell a guy that it's better to buy an American-made machine with stepper motors than to buy a Chinese or an imported product with all the servos that they can give you. More than likely, and I'm just being honest, the servo motor that came on that import product is probably not very high quality. More than likely. They're going to try to build you a cost-effective solution with all the bells and whistles. Where are they cutting the corners? They're cutting them on the things that you don't really see. Not up front, you don't see it, right? It has servos on it. Okay, you got me, buzzword, right? It's got servos. It must be good. No. What servos are on it, right? You got to start asking some of those questions because there are places where servo motors and stepper motors can affect you in your application, right? Let's just start off. Let's name off some of these. You know, Chad, what comes to mind when you think about how can a stepper or servo motor affect my application? If I ask you that question, what are you going to tell me?
Reliability.
Reliability. Yeah, I think of cost. That's another area that I think of. What's another area that you think about, Chad, in terms of the areas of, let's go into
Performance.
there you go. Yeah, performance. That's another one. So let's go into. I was going to say before I had you say that, I was going to actually say, let's step back real quick. Let's talk about these, right? So we named three of them: reliability, cost, and performance. Let's talk about them a little bit here. So talk a little bit about reliability, Chad.
They generally offer a lower cost to the end user, so you can save on upfront costs by giving up technology. But obviously, when you give up technology, you're going to give up performance.
Yeah. So they're kind of all tied together. Exactly. So from a reliability standpoint, generally cheaper equipment comes with cheaper electronics, right? Well, what does that do? That usually decreases reliability. You can't depend on that machine long term because realistically, a cheap motor will lead to either communication issues down the road or lead to interference from other equipment. That's something to think about. Lower cost servos don't have as much built in place for tuning. Therefore, they can't isolate noise. Well, a servo motor runs off of amplified noise. So if you have a welder or you have something else running in your shop, there's a chance that noise is going to interfere with the machine, even on a good servo motor, right? I mean, putting a welder next to a servo-driven machine is a bad idea. It's generally going to isolate if you don't isolate that noise. So you generally need a higher quality electronic. So that's what I kind of laugh at is you look at some of these cheaper machines out there, lower cost machines, and they're selling to the, plasma machines as an example, right? You can buy a $5,000 plasma machine out there, but they're trying to advertise they have servos. I can promise you it's not a very good servo system, right? It costs almost that for a good servo system. So now you're going to put this cheap electronic system in your weld shop because where do people put plasma machines? Typically in their shop. Well, next to their welder typically. Well, now you're putting off this high frequency and it's interfering with the machine and they wonder why the machine's not cutting good. Well, you have other things that are causing problems in the environment. So you got to think about that from a reliability standpoint. A high quality stepper motor is better than a low quality servo. I will say that. Just because it's a servo doesn't make it quality. A lot of companies try to cut corners to put cheap electronics on their machines so they can advertise those buzzwords, right? Servo motor. No, that doesn't necessarily make it better, like I just talked about. You must understand what you're buying and ask the questions before you buy them. And it relates to cost. When we talk about that next category of cost, stepper motors generally offer lower cost to the end user. There's no way around it. But so do cheap servos. So just because they have servo doesn't make it a better product. You need to ask questions. Therefore, you could save on upfront costs by giving up technology, but some technology, is required for certain applications. If your application doesn't require it, great. I mean, then you can just buy cheap, right? But how many people who own businesses don't have some requirements, right? Most do, right? Mm-hmm. There's something in your business this part has to be within a certain tolerance. Okay, well then, depending on what the tolerance is, you might need to think about a better motor. Or I have to be able to cut this material at this speed, otherwise it burns or it melts or whatever, right? Plastics. Mm-hmm. There is such thing as too slow. You end up with an issue. Well, if your machine can't cut because the torque level's not high enough, you're going to have bad cuts on everything you do. That machine's pretty much useless to you. So it relates back to performance, right? Stepper motors are great at lower speed applications. However, if you're looking to achieve maximum performance, you might need to consider servo motors. Typically, AC digital technology with a higher performing encoder technology is what you want. As you start getting into better machines, you're typically going to go from a DC motor to an AC motor. You're typically going to go with more encoder count. What encoder count? What the heck does that mean?
How many times the motor checks itself per revolution?
There you go. So we talked about it earlier. You break down those in a single revolution. Mm-hmm. You break them down into steps. Well, steppers have certain steps they can only stop on. Servo motors can stop anywhere. There's no certain stopping points. There's not a magnet. So the advantage to a servo is it can check itself more frequently. So the higher the number of encoder, the more accurate the motor itself is.
Correct.
Yeah. And we have machines that range from what? 10,000 to...
$1 million.
Yeah, $1 million. I'll say just over $1 million. I think it's 1 point something million. But you can literally check... Think about that. One revolution, 360 degrees. It checks itself 1 million times. How accurate is that motor? Like the chances of it missing something is slim to none.
Well, then there's the plastic encoder versus glass encoder.
That's another thing. Let's talk about encoders. Plastic versus glass. So just because it checks itself a million times doesn't mean that it's 100% accurate either. If it has a plastic encoder, well, what happens to plastics when it gets hot?
It's going to swell.
Yeah. What happens to them when they cool or they get cold? They contract, right? You have to start thinking about that your motors are going to change temperature just from daily temperature. If your shop temperature one day is 70 and the next day it's 90, your machine's changed.
But you've been going for 7 hours.
There you go. Now, let's say you're a cabinet shop, right? You run your machine all day long. Well, I promise you, the temperature in the shop was cooler in the morning when you started at 7 a.m., but also the machine was cold. Now you've been running it all day long. It's gotten hotter outside. Your shop's warmed up, whatever it is. Now the machine's warm. Your machine is not cutting the same accuracy as it was at the beginning of the day if you're looking at cheaper motors. It's something you have to think about. And my favorite thing is that you get these guys that run multiple sheets, right, over multiple days. You got a guy that has to run 80 sheets, right? Well, we're going to do that over 2 days. Okay. I better hope that if your machine's not a high quality machine, that your temperatures in your shop are the same both days. Otherwise, you have an accuracy difference from the first half of your job to the end of your job. And I've seen it. I've had guys call me up. I've had cabinet guys call me up. I have a machine here, and it seems that every time I run, these long jobs, the end cabinets don't fit the same as the beginning cabinets. Well, it's because you set all your zeros based off of the initial. And you start looking at it, and it's fortunately, these are not ShopSabre customers. These are guys who are looking at ShopSabres. But because these cheaper machines did not have the technology, it's causing them problems in their real world.
ShopSabre.com.
That's where you go to solve that problem, just in case you're wondering. Now, we talked about it briefly, but AC versus DC technology, right?
DC is a shoe brand, though.
Yeah, it is also a shoe brand. You're correct. Good job. It's also a place in the world.
So air conditioning.
Washington,
versus,
D.C.
AC/DC is a band.
Yeah, you can have all of them together.
So air conditioning, discomfort.
That was pretty good. I was pretty ready on that one. No. So AC power versus DC power is what we're talking about here. Generally speaking, DC motors max out at a certain load, at a certain torque before you need to go AC. You cannot produce as much torque from a DC motor as you can an AC motor. You can get more power, excuse me. So AC motors are going to produce higher capacity. Generally, when you look at motor ratings, they have NEMA ratings on a stepper motor, watts on a servo. Generally, you don't get a servo motor with an
ounce rating.
Yeah, an ounce rating. Excuse me, that's the word I was looking for. Ounces. Ounces versus watts, not NEMA. I apologize. NEMA is the size of the actual motor. Yeah, it's the casing size. But the ounce rating, excuse me, is the actual output of a motor. So guys will say it's a 1,200 ounce servo motor, right? That means that's what it puts out. Now, 1,200 ounce steppers are pretty dang strong. Most stepper motors that you see guys using in cheap equipment are 200, 300, 400. That's the problem, is they're just not strong enough. When you look at a servo motor, one servo motor a lot of times can output all the torque that you have of all the stepper motors on the one machine. That's how much difference there is. And so when you start looking at that, you got to talk about when you get into higher torque applications, the AC power motors are generally going to be what you find. If you start looking at stepper motors with, low torque, they're DC motors, obviously, and they're generally going to be low torque comparably to a servo system, right? So there is a place for AC and DC, obviously. They're generally speaking, if you look at a company and you say, hey, are your motors AC or DC? You'll see a difference in different motor brands typically from that alone, because certain motors only come in DC. Certain motors only come in AC. For us, we use a lot of name brand stuff. That's one thing I always talk about, is that you want to know the brand of the motors you're buying. There's lots of brands out there. A lot of reputable brands that you might know too. Mitsubishi is one. We tout Mitsubishi a lot, but Mitsubishi, Panasonic, Yaskawa, these are all brands that people might recognize, right? But you have to also look at, there are a lot of brands out there you might not even know, and things that you've never heard of. So you got to be careful when somebody says, I'm putting a Bob servo on my machine. Well, just because it says servo on it doesn't make it a good servo. Who's Bob and how good is his servos? You got to start looking at the encoder count. You got to start asking what kind of encoder is it, plastic or glass. You got to talk about the torque rating. Is it an AC or DC motor? You also should be asking, is it brushed or brushless? Because there are some servo motors that have brushes in them. You see them in drills, right? You get drills that have brushes on them and they go out. They wear out.
I was about to say, does that mean those wear out?
Yeah, they wear out on your servos. And there's old school servos that used to have to tune. You had to have a guy come out and tune them. Gotta be careful of that too.
And
That's extra cost.
There's a lot more to this motor stuff than
didn't-
I anticipated.
yeah, I guess I didn't realize that there were brushed servo motors.
Yeah.
Because obviously we use brushless.
Yeah, we've always used brushless. We
Because
have.
I don't know.
Yeah, no, correct. I mean but that's the point. Is
Yeah.
you've never had to worry about it because we don't build the cheaper stuff, right?
Yeah.
It's not a problem. You don't hear about it. But yeah, there are motors out there that have brushes in them and they require maintenance. But there's a lot of companies that have traveling tech guys because that reason alone. They have to go tune the machines. With our machines, you don't tune anything.
Is that literal brushes in the motor? Is that what brush?
Yeah,
means, or is it
they're brush is the terminology, but yeah, it's an
like
electronic.
bristles or
No, not like
Oh.
what you're thinking of right now. It's not like a
I can
hairbrush.
show you a picture of
Yeah,
one.
we'll show you. We got pictures. We can post them even.
But you have to replace them. So, like, you'd have to take the motor off, go into it, replace it. So, like,
Yeah.
periodically, you'd have to do that to the machine. Which,
Correct. And then you got to hope you're doing it right. And then obviously you got to touch on, open loop versus closed loop. We talked about that a little bit, but there's what I refer to as three of them really. You hear open loop and closed loop, but there's actually three: open loop, closed loop, and complete loop. Open loop means the motor's dumb. It doesn't know anything. It's Garrett driving across the road with a road map and hoping he gets it right. Then there's closed loop, which is add the GPS system to it, right? And then you have complete loop, which is it can make a change on the fly. That's autopilot. It missed the turn, but it can actually get you on course, right? It knows what to do. So generally speaking, open loop, cheapest machines out there. Cheapest applications. Closed loop, most popular. It is the most popular system you can find in any industrial application. Generally, that is your main machines worldwide. And then you have your elite machines, which is complete loop. And generally, when you look at that, that means it's controllers with closed loop feedback. They're generally, you're talking machines that are over $100,000 easily. I mean, some of these machines are $1 million. You start getting into a completely different application at that point. So when you're looking at, routers, plasmas, that world, closed loop is ideally what you're looking for. So did I bore you yet?
there's a lot to it.
Did a lot of talking.
I thought it was a good episode.
Yeah. I mean, I think, servos and steppers exist for a purpose. One is not better than the other just because, otherwise the other one probably wouldn't exist, right? It's kind of that rack and pinion versus ball screw argument. They both exist for a reason. We use them both. Same with steppers. Just steppers and servos. We use them both. Like there are applications where steppers make sense. There are applications where servos are necessary. Now, they are application specific, so you must understand your needs, your expectations, and the specific brands you're considering. Otherwise, you're not going to be making a decision based off of anything other than feelings, right? I've always told people, you don't make decisions off of feelings alone. You try to base them off of facts and technology, because ultimately that will always lead you in the right direction. And, trusting a reputable company who does their engineering goes a long way. It's something that we're very good at. It's something that I will say that ShopSabre's engineering department is second to none.
That's right.
ShopSabre.com.
Yeah, ShopSabre.com is a good one too. You can definitely do that one.
ShopSabre.com.
That's what I thought you were going with it, to be honest.
Yeah, I know. That's why I changed it up for you. But it's something to think about though, because a Chinese company or an import company, right? These companies that sell mass products at low prices, are they spending a lot of resources doing engineering typically?
No.
No, generally not. Generally, your quality comes from companies who do more quality-based sales than they do quantity-based sales. So when you start looking at, an import product, they're built for a cost generally. How do you sell import products? Low price, right? When you see a sales guy selling on price, he's generally trying to hide other features that you're going to probably not like. Generally, when a guy's pushing on price and you look at the price, we're the cheapest machine around. I don't know why you'd spend more money, blah, blah, blah. Generally, it's because you're giving something up. They're not performance-based. Generally, their electronics are, a bigger failure point, so they're going to talk about the price tag, right? It's easy to, well, you don't need that because it's so much cheaper, right? You don't need that tool changer. We don't sell tool changers on any of our machines, so you don't need them. Well, why? I need a tool changer. I'm a cabinet guy. Of course you need a tool changer, right? So if they can't sell you different models for different applications, are they really looking out for the customer? No, they're just selling product. You look at a lot of the reputable companies, obviously I'll speak for ShopSabre, but we have different lines for different applications, right? There's a guy that needs a different machine for his application than the next guy. So having the same cookie cutter machine for everybody doesn't solve the problem for the customer. We sell machines based on a need. That's where consultative sales comes in. That's where, Chad, that's what you do all day long, right?
The same with choosing like a vacuum pump.
Correct. Yeah.
A vacuum is solely based on what the person's doing and power available.
Exactly. So if you buy different spindle heads, your router motors, and you buy different vacuum pumps based on your application, you should probably think about the motors on your machine as being the same, right?
Exactly.
So, there's a lot of things that you can look at, but your biggest failure points a lot of times are electronics related. Machine, metal doesn't wear out a lot of times, right? You're not wearing out the machine frame in most applications, unless your machine's really bad. But generally speaking, the frames, it's easy to bring, you see these guys that bring machines in over from overseas. They're buying a lot of the steel, and they have a steel frame, and people think, oh, it's a steel frame, we're good. But it's the things outside of the steel frame that cause problems for you. You start looking at, if the frame wasn't built square, right? Now how's the motor's going to react to that? Right? You're putting more torque on that motor. And if the motors aren't aligned properly, or if the rails aren't aligned properly, it's more torque, more wear, binding on your motors. It all trickles down to that. Your electronics are what end up failing. Your bearings end up failing. Something happens, and you end up having a problem. So you really need to trust name brands and reputable companies. I mean, I say that wholeheartedly because a lot of the knockoff companies out there, a lot of the knockoff brands, parts, they are that reason. They're cheap for a reason. They try to saturate the market, and then basically when things fail, it's not their problem because they've already got your money. They're not going for return customers, right? They're going for the first time sale, right? Get the first time buyers. There's plenty of them out there. Just keep selling machines. ShopSabre, being that we offer lifetime support and we do a lot of that stuff, you think about that. Lifetime support, right? Like I gotta help you for as long as you own that machine. I don't get to collect more money from you for that. So why should I use cheap stuff on that? It doesn't help me. The only person that helps when you put cheap stuff on it is the company who sold you it. Because at the end of the day, they saved money, you didn't. It's going to cost you money one day. You're going to spend the same amount of money. So as you start going through it, you have to think about what you're buying, why you're buying it, what you're doing,
True that.
Other weaknesses, we're slow learners, and we're not particularly good listeners.
And then there's some sales guys like that. They just sell you what they're told to sell you. They read out of a manual. So that's what I know today. Hopefully I didn't bore everybody.
That's a lot of knowing.
A lot of knowing?
That was a lot of know.
Helen, we're both in sales. Let me tell you why I
suck.
suck as a salesman.
Yeah, it's, there's a lot of sales guys that don't understand what they're talking about. They spend more time worrying about how their sports team did than they do understanding the product that they sell.
Well, I think we see that when we do competitive analysis against our competitors and
Yeah.
the lack of information on the quote and emails that they send out. So
Yeah.
it's like they want people to know less, so they just purchase and
Yeah.
have to deal with it then.
Yeah, you ask them questions and they just completely ignore them, right?
What was the CFM on the vacuum pump they quoted? Well, I don't know. Did they ask you for different ones?
I
Or
see your lips moving, but I can't make out the words.
doing tool
I'm
changer?
deaf.
You gonna hold it down with vacuum?
Yeah. That's the problem is that you get guys that they sell those machines exactly. And I just laugh because like you said, we do competitive analysis. And when we do our competitive analysis, we see what they're selling people and we're like, do you even understand what they're selling you here? And a lot of times they don't. Well, they said that as a vacuum on it. Yeah, but the vacuum's designed for a 4x4 machine and you have a 5x10,
And you need 3-phase power.
Correct. Yeah. And you look at that from people and really with servos, stepper motors, I think it's the same thing.
Exactly.
I think most sales guys couldn't answer a question about the servos or steppers or even know what to explain to you.
They're hoping that they don't get asked.
Yeah. They're hoping you don't ask questions. Just sign here and here, right?
You have
That's
to
what
be
they want.
you have to be a smart shopper these days, though. It kind of reminds me of a couple years ago on eBay. Had that issue with people selling like a picture of an Xbox.
Oh,
And for $400, they'd send you an actual picture of the Xbox that you wanted to buy.
Yeah.
It says in the description, this is just a picture of the Xbox. You're not getting it. Well, people still bought it.
Yeah, because they didn't read.
You got to look into this stuff before you buy it. Don't just go, especially on, that's some $400. Then you add a 0 to it, 2 zeros to it. You know, like,
I guess I like
Look into
showing
it.
people the Alibaba site so they can see how cheap some of those
Right.
machines are.
I think that's the best thing to do because people are looking at, they're like, I'm buying this $40,000 machine from so and so.
It's like, no, they're gonna make 35 off
Yeah,
of
they're
you.
making 35 grand on you. You know, so you know what? I got this weird feeling in my stomach right now that
You're
my
hungry?
phone system needs my attention.
I got a weird feeling that I'm hungry.
You're hungry? Oh, so we should keep going then.
All right. I'll see you guys.
But with that, I'm Brandon.
I'm Chad.
I'm Garrett.
Thanks for talking shop with ShopSabre.